Hey there, in this tutorial we are going to discuss how to assign a smart contract to an already existing SFS NFT using Hardhat. And just in case you don't know what Hardhat is a development environment that provides you with tools that you need to develop smart contracts on Ethereum and other EVM based blockchains. So to get started, we need to have a couple of things set. You need to have Node.js and npm installed. You need to have MetaMask with your public and private key. You also need to have a basic understanding of Solidity, and last but not the least, you need to have an SFS NFT token ID, which you're going to use to register your smart contract. So with that being said, let's dive right into it. First thing we're going to do is to create a project, and we're going to be doing that with Hardhat. To do that, we're going to initialize a JavaScript, a Node.js project rather, with npm. So we're going to do npm init -y, and the next step is to install Hardhat --save --dev. We're going to install Hardhat as a dev dependency. So let's wait for Hardhat to install. So now that we have Hardhat installed, the next step is to initialize a Hardhat project. To do that, we're going to hit npm Hardhat init. I'm going to just create a basic JavaScript project. Yes, everything. So let's wait for our project to initialize. So our project is done initializing, and it generated a couple of files and folders. But our main focus in this video is going to be the lock.so file. So this is smart contract we're going to deploy. For the sake of simplicity, we won't have to write our own smart contract. So we're going to deploy this smart contract to the mode network, and this is what we're going to assign to this SFS smart contract. Before we start implementing the assign function, I think we should take a look at the assign function on the SFS smart contract to understand how it works and get a clear view of what we're about to do next. So I'm currently on the mode explorer, the testnet. It's a polyar testnet, and I'm currently looking at the source code of the free sharing smart contract, which is the SFS smart contract. Okay, yeah, so this is the assign function. This is the function we are going to interact with in this video, and as you can see, it's just a basic function that takes in a token ID and check if the token ID exists. That's the NFT, and if it does exist, it's going to assign your smart contract to that token ID right here. And one thing to note is that you can only call this function, or rather you're supposed to call this function through your smart contract. You're not meant to call it with your own account, and that's because it recognizes the smart contract as the sender. So that's one thing to take note of. And to be able to do this, there are two ways. You either call this function in your constructor, or you do it as a standalone function. Maybe you want to call the function, maybe you want to assign your smart contract later on. You can create a function and then call that function later to invoke this assign function in the SFS smart contract. Second thing to note is that this action can be done only once. So you cannot register or assign your smart contract twice. You can do that only once. And then lastly, this assign function does not mint NFT. If you don't have an NFT, or you don't have an NFT token ID, you should try registering your smart contract instead of assigning it. So now that we have seen what the assign function is all about, let's go back to our code and implement it. So we're going to implement it with, I'm going to create an SFS contract here, and then create a function, assign, and it's going to take in a unit token ID, and it's a public function that returns 256, returns, I missed the S, yeah. Our next step is to create an instance of this SFS smart contract here and invoke the assign function in it. So I'm going to go inside the constructor, and then we're going to create an instance of the SFS smart contract here. So I'm going to call it SFS contract equal to SFS, and we should pass in the token address here, the smart contract address, sorry. So to get the smart contract address, we're going to go to the mode documentation, go to the testnet contract address information, and here we can copy this SFS smart contract address right here. And we'll go back to our code and paste the smart contract address right inside here. And next step is to invoke the smart contract, invoke the assign function. So I'm just going to use a random token ID. I'm going to use 2 here. This is where you put in your own token ID. But for the sake of this tutorial, I'm just going to keep it simple and use a random token ID. So that's basically it. Let's check if our contract works and compile it. npx hardhat compile. And let's see. Yeah, our smart contract compiled successfully. The next step is to deploy our smart contract to the mode network. To do that, we need to first of all set up our Hardhat config. And to set up our Hardhat config for the deployment, we need to add a new property. I'm just going to paste it here, called the networks. So we're going to add a mode network here with this URL, the chain ID, and the account. And I got this information from the mode documentation. You can see it here. You can see the mode. You can see the mode details here, the RPC endpoint, the chain ID, and everything that you need. If you want to deploy to the mode mainnet, you can see the one for the mainnet here as well. Almost the same thing. So that's where I got all this data that I'm using here. And then for the account, this is where you put in your private key. So I'm going to paste my private key here. So that's it. Now we've set up our deployment script. And the next step is to run the deployment itself. So I'm going to run npx hardhat run script/deploy.js, and then we're going to specify the network, which is going to be the mode network that we just set up right now. Then we hit enter. It's going to take a while for it to deploy. Alright, so our smart contract has been successfully deployed. So I'm going to copy this smart contract here, and let's check if our smart contract was actually registered to the SFS smart contract. So I'm going to go back to the Explorer here at the SFS smart contract. I'm going to check the read contract, and then I'll check the is registered function here. Paste now our smart contract and click on query. And as you can see, it says that our smart contract has been registered in the SFS smart contract. So that's basically it. That's how you assign your smart contract to an already existing SFS token ID.